group number for oxygen. So I'm going to use my periodic table for that. Now oxygen, to find the group number, I just go straight up because groups go up and down. So the group numbers you're going to see are the numbers that we have kind of written all the way across here from 1 to 18. Oxygen is in group number 16. Period number. Now periods go left to right, so the period numbers are actually written along the side of the rows here. So I want to find a period number here for oxygen. All I have to do is go left or right, and I'll find that period number. So oxygen is in period number 2. Now metal versus nonmetal. I know that the zigzag line on the periodic table here separates the metal side from the nonmetal side, and I can easily see that oxygen is on the right side of that zigzag line, so it's part of the nonmetals. Number of protons. So to find the number of protons, all I need to do is look at the atomic number. So oxygen's atomic number is 8, so it has 8 protons. Total number of electrons in a neutral atom. Well, I know that it's a neutral atom. The protons and electrons would be the same amount. So I'd start off with 8 electrons in a neutral atom. Number of valence electrons. Now valence electrons are only the electrons that are in the outside energy level. So to find the number of valence electrons, all I have to do actually is find the number of dots that I draw for my electron dot diagram. So oxygen has 6 dots, so it has 6 valence electrons. So if you want to make a note for yourself, this is the same as the number of dots. And then I'm going to draw that electron dot diagram here. So I'm just going to put down the symbol for oxygen and draw my 6 dots around it. All right. Add or lose electrons and how many? So you might remember earlier in the unit, we practiced creating ions to make atoms more stable. We know that the best number of electrons to have is 8, to have a full octet. If I don't have 8 electrons, then I either add or lose electrons to try to get to that octet. I will lose electrons when I have less than 4 dots. So if I have less than 4 electrons, I lose them to create my octet. And if I have more than 4 valence electrons, then I add on to fill in what's missing. So if I'm missing a couple of electrons, I add what I need to. Okay, so that's what we're going to do here. So oxygen has 6 electrons, so it's more than 4. So he's going to add electrons, and he just needs to fill in the 2 that are missing. So he's going to add 2 electrons to fill up its octet. Now the ion notation. Ion notation is where we write down the symbol with a charge. Okay, the charge should be written kind of as an exponent. So it's a positively charged atom if it's losing electrons, because you're getting rid of negatives, and it's a negatively charged ion if it's adding electrons, because they have negative charge. So in the case of oxygen here, I'm going to write my symbol. We're adding electrons, so I should make it a negatively charged ion, and we're adding 2 electrons, so the charge number becomes -2. All right, cation or anion. We know that cations have positive charge and anions have negative charge. So I have a negatively charged ion here, so that's an anion. Number of electrons the ion has. So to figure out that answer, we did some of that practice also earlier. To figure out how many electrons the ion has, we do a little bit of math. We'll take the original number of electrons, which is the same as the atomic number. If you are losing electrons, you subtract to get the number of electrons for the ion. If you're adding electrons, you take the original number of electrons, or the same as the atomic number, and of course you're adding to that to get the number of electrons for the ion. Now, if this is correct, of course, it should match the atomic number of one of our noble gases too. So there's an easy way to check our work on that. So I'm going to take oxygen. It originally starts with atomic number 8, which is basically 8 electrons total. So I'm going to start with my 8, and then I'm adding 2 more electrons, we said. So that will give me a total of 10. All right, so you can start with your atomic number, or you can start with the total number of electrons in your neutral atom. So either of these numbers, of course, is exactly the same answer. And then what are you doing with the math? Are you adding or are you losing? Now we said if this is correct, it should match one of our noble gases. So if I look at my noble gas column, number 10 is neon. So it should match one of the elements that's in the noble gas column here. So that matches neon. And then I know I've done that problem right. Now, number of energy levels in the neutral atom. So to find the number of energy levels, all you need to do is find the period number. So oxygen here, if you go to the side, has 2 for the period number, so it should have 2 energy levels. Number of shields in the neutral atom. Well, we learned that the number of shields is always one less than the number of energy levels. And we talked about shields that get thrown up here. If you have 2 energy levels, only the inside level makes a shield. The outside level never does, so you'd only have 1 shield. Or if you have 4 energy levels, you'd have 3 shields, because again, that outside valence shell does not make any shields. It's just the inside core electrons that are making shields. So in our case here, we have 2 energy levels, so we should have 1 shield being produced. It should always be 1 less. So that's how you figure out the information in your data table, and you guys will do the same exact thing for tellurium. Okay? Once I have that done here, I'm going to go over here and draw my Bohr models. So to draw the Bohr models here, we have some requirements. First, it says that we want to draw them in the correct direction. Because ours are in a group, which is up and down, we've got oxygen and we've got then tellurium below it. I'm going to draw them in that same direction on my paper. So I'm going to put oxygen up top, just like it is on the periodic table, and then I'm going to do tellurium below that. And you can just write the symbols if you don't want to write the names down, that's okay. Now we're going to include the following information. So we're labeling each element just like I've done here. We're going to draw the correct number of protons. So protons we said was 8 protons. So I'm going to draw 8 protons. I'm just going to kind of put that kind of in the middle where the nucleus would be. I don't need to worry about what the neutrons is, just the protons is fine. Then draw the correct number of energy levels. Okay, so we said energy levels, that there are 2 energy levels, right, in our neutral atom. So I'm going to draw 2 circles for electrons. Draw the correct amount of shields. So we have to draw 1 shield. So that should be on that inside level. So I'm going to go ahead and just draw a shield, just draw kind of a line going across there to represent the shield. And then I have to draw the correct number of valence electrons. So valence electrons is 6. So I have to draw 6 valence electrons. Those go in the outside circle here. So 1, 2, 3, 4, 5, and 6. Okay? And that completes the requirements that I need for my Bohr model. Okay? I have the correct number of protons showing. I have the correct number of energy levels, shields, and valence electrons. Okay, and I've labeled what my element is. You would do the same type of thing for tellurium. Now, those of you who want to do this electronically, if you're on your iPad, you can also do this electronically. You could Google, if you want to, a model of an atom. You just have to be careful. So here, for example, is a model of an iodine atom. Okay, now it's showing dots and as well for all of the electrons. So we see all the electrons that are in the core energy levels. You don't have to draw the core electrons, but again, if you Google it, you can just copy and paste that picture. That's fine. But this one did not show me the number of protons in the nucleus, so I just wrote that in, 53 protons for iodine. And of course, it's not going to show me the number of shields, so I'm going to have to draw the shields in. So if you do want to use one from the internet, then you have to make sure that you are adding any details or information that that picture might not have. So some models will have the number of protons in the center and some don't, so maybe you choose wisely there. And none of them, I don't think, are going to have any of the shields. You're going to have to for sure draw the shields in. So either do that in Notability, or you can do that with your like Google drawings or something like that. Or again, you can just hand draw stuff. Okay? All right. Now the last requirement here, actually, that I'm going to do here, which is the trend. Please make sure you don't miss the trend. Blank is more reactive than blank. So we have to decide out of these 2 elements, who's more reactive than the other one. So I'm going to take a look at my periodic table. So we've got oxygen and we've got tellurium. I'm on the nonmetal side, remember. I know that the most reactive nonmetal is fluorine. So I kind of think about who's closer to fluorine. Oxygen's closer. So when you're on the nonmetal side, it's more reactive as you go up and to the right. So oxygen is further up than tellurium. So oxygen I would expect to be a more reactive element than tellurium. Okay. Now if I was on the other side of the periodic table, remember that on the metal side, francium is the most reactive, so I would want elements that are closer to francium to be more reactive. So make sure that you know which side of the periodic table you're looking for. Should I be getting closer to fluorine or should I be getting closer to francium? Okay, so that's how I complete the front side of this paper. Remember to do tellurium in terms of the information here as well as the drawing. Now on the back side, if you'd like, I'll work through, again, one example on the back here. If you want to do it by yourself, you can turn off the video and watch it yourself. So on the back side here, it's the same kind of information. We're doing it for the period trend. So I'm going to go ahead and do sodium, Na, and then you guys will do aluminum by yourself. So it's just spread out a little differently here. Remember, periods go left to right. So atomic number I'm given, the group number for sodium, if I look on the periodic table, group number for sodium, Na, I go straight up, it's group number 1. period number for sodium, I go off to the side for the period number. It's period number 3. Metal or non-metal, if I look, of course, on my periodic table, Na is on the metal side of the periodic table, left side of the periodic table. Number of protons, of course, it should be the same as my atomic number, so that's number 11. Total number of electrons in the neutral atom should equal the atomic number. It should be the same as the number of protons if it's neutral. Now, number of valence electrons, remember, that's the same as our number of dots. So I just look on the periodic table. Na has 1 dot, so it should have 1 valence electron. And so when I draw my picture here, I'm just going to draw 1 dot for my valence electrons. Again, you're going to do the same type of thing here for aluminum. Over here, Na, add or lose electrons and how many. So if I want to add or lose electrons, I only have 1 valence electron, so that's less than 4. So if I have less than 4, I should lose electrons. And I only have 1, so I'm going to lose 1 electron. Ion notation, remember, we're going to write down the symbol with the charge. So my symbol is Na. When I lose electrons, I make a positive ion. And he's a positive 1 because he's just losing 1 electron. And positive ions are called cations. Number of electrons that the ion now has. So that's where we had to do a little bit of math work here, right? So we're going to start with the atomic number and either add or subtract electrons. So my atomic number originally, slide that over here, atomic number was 11. So my math work here, 11. And then I said that I was going to lose 1. So I'm going to subtract 1 electron from that. 11 minus 1 gives me 10 electrons. So again, you can start with your atomic number, and then are you adding or losing? Now that should match one of my elements on the periodic table. That's in that noble gas column. And once again, number 10 is neon. So that's a good match here. Number of energy levels. So for sodium, number of energy levels is the same as the period number. So it should have 3 for the number of energy levels. And then the number of shields we said should always be 1 less. So 2 shields. Okay. And then you'll do the same thing again for aluminum. Now, drawing the Bohr models down here, we should draw them in the correct direction. So we're doing Na and Al. So if I'm doing Na and Al, Na is on the far left, and then as I work my way across, you'll see Al. They're in the same period. So I'm going to do aluminum first. Oh, sorry, not aluminum first. Apologies there. Sodium first. And then over here, I'll do aluminum. Okay, so I'm going to do them in the correct order. And they should be really in the same order that you're seeing them on the paper here. So Na, and then if I go across, you'll see Al. Now, to draw the picture here, so I've labeled them. I'm just using the symbols on this side. Draw the correct number of protons for Na. My proton number is 11. So I'm going to start with 11 protons. Correct number of energy levels. So energy levels, I have 3 energy levels. So I'm going to draw 3 circles. Correct number of shields. So shields, I have 2 shields. So remember, it's the inside levels that make a shield. So that one's going to make a shield, and this one's going to make a shield. And that's fine. The outside level doesn't create a shield. And the correct number of valence electrons. So my valence electrons, I have 1. So I'm just going to draw 1 dot. And there's my model for sodium. You'll do something similar for aluminum. Now, if I'm aiming for an A when I'm going for the summative, I would want to make sure that I can tell the difference in the size of the atoms too. Which one should be bigger, which one should be smaller. Okay, same thing here. Which one should be bigger, which one should be smaller. I think it'll be pretty obvious there. So again, you can Google a picture if you're doing it electronically. Just make sure it has the details that you need. Otherwise, make some edits to those drawings so that you can add the information that you need to. And then finally up here, we're going to take a look at the trend. Who is more reactive than the other one?